putting it all together, given this polynomial function f of x equals negative 1/3 times x minus 1 times x plus 3 squared, let's analyze this. First, determine the zeros of the function. And the zeros of the function just mean that we are going to find where does it cross or touch the x-intercept. And we do that using the zero product property. So we will take the function negative 1/3 times x minus 1 times x plus 3 squared and set it equal to 0. Then the zero product property says one of these factors must be 0 if the product is 0. Well, we know negative 1/3 is not 0, but x minus 1 could be 0, or x plus 3 could be 0. We don't really have to solve that twice. So if x minus 1 is 0, x would be 1. If x plus 3 is 0, then x would be negative 3. I just wrote that twice. So if we have the 0, negative 3, and we want to determine its multiplicity, we go back to the function. It has an even multiplicity, so it's multiplicity of 2, so we know that it touches. And we can write that x-intercept as negative 3, 0. Then we have a 0 of 1. We go back to the function, and it has degree 1 for that factor. We don't usually write that 1, but we know it's there. So we know because that is multiplicity 1, which is an odd number, it crosses, and it crosses at 1, 0. Determine the y-intercept just means on the y-axis everywhere x is 0, so we just evaluate the function at 0. So we get negative 1/3 times 0 minus 1 times 0 plus 3 squared. So we have negative 1/3 times negative 1 times 9. So that looks like we're going to have positive 3. So the coordinates are 0, 3 of the y-intercept. The maximum number of turning points is 1 less than the degree, so it's 2. And then our end behavior, our power function is y equals negative 1/3 x cubed, because the leading coefficient is negative 1/3 and the degree of the polynomial is 3. So we know as x approaches infinity, f of x will go to negative infinity, and as x approaches negative infinity, f of x will approach positive infinity. So we can curve sketch with all this information. I'm first going to plot all the points that we know. We know we have an x-intercept of negative 3, 0 and positive 1, 0. We also have a y-intercept of 0, 3. And starting with the left end behavior first, I know I'm coming from very large positive values in y because f of x is approaching positive infinity as x is coming from very large negative numbers. And I know I have to touch at negative 3 because the multiplicity was 2, which is even. And then I can see that I'm going to cross through the y-axis because that's my y-intercept. And then I cross down through 1 because 1 is a 0 and it has multiplicity 1, which is odd. So I just sketched that curve by hand with all of that information from A through E. Let's confirm that with Desmos. So going to Desmos, I have a function in here from a previous problem, but we can quickly just go ahead and delete that and type in this function. So I have negative 1/3 times the quantity x minus 1, it's starting to shape up here, times the quantity x plus 3, and then I just do a shift 6 for the caret key and put a squared there. And as we can see, other than due to the scale of what I sketched by hand and this Desmos graph, I can spread this out a little bit. you can see that what we sketched by hand using our analysis matches what a graphing calculator would show you if you put it into a calculator. Whoops, did not mean to move it up out of your way there. There it is again. So that closely matches what we did on our paper through our analysis.